we're now at the point where we're actually going to be going through Atlas and running a prediction. So everyone should have been given this kind of piece of paper that tells you what we were doing during the day in the morning. Does everyone have one of these? So on the bottom of corner, there should be a user and then a number. So you should have a number between 1 and 50. So this is going to be your username for RStudio and Atlas. Actually, is it just Atlas? Or is it RStudio as well?
It's just the RStudio.
Oh, just for RStudio. So Atlas, you can just go on without a username. But for the RStudio, you're going to need that username. And then the password for everyone, for every user X is going to be password 1. So P capitalized, and then the rest of the password non-capitalized, and then 1 at the end. So that's going to be your login for the RStudio.
So it's without the space, so user and then directly the number.
Yeah. Oh, yes, yeah. There's a space there which shouldn't be on. You can be user 31. So we're actually not going to use RStudio at the moment, so you don't have to worry about logging in for now. But I will ask everyone to go to this Atlas link. So if everyone wants to go to this Atlas link, that is plp-odyssey-tutorials.amazingaWSdemos.com, then you should get a version of Atlas that will be used just for this tutorial. And for the Atlas, you do not need to log in. You just have to agree. When you load that page, it will come up with an I accept. Make sure you accept or you agree, and then the Atlas will work. So this is the Atlas that I'm on. So when you were on, you would have been on the home page. We're going to go to the first step of actually going to the cohort definition. So the cohort definition now contains some cohorts which Patrick worked on. So after our exciting conversation this morning of the best prediction ever, he went off and actually started making the cohorts for the predictions that we wanted to focus on. So I'm just going to run through the logic that he had for the cohorts, and I'll show you how you can actually use these. Let me dismiss the meetings. So can everyone see the screen, or do you want it zoomed in? Let me see if I can zoom in. Okay, so the first prediction we were looking at was going to be the target population was going to be pregnancy with SSRI use. So we click onto this cohort, so cohort 22, and so if people are playing with this, please don't save any edits. If you make any edits, please don't save it, because we're going to be using these cohorts, and anyone can edit them at the moment. So avoid pressing this green button or this red button. Definitely don't press this red button. So the logic that Patrick used to create this cohort was he was looking for a drug exposure of SSRIs. So that was going to be the index date that he picked. And he wanted them to have at least 365 days prior observation. So that was the data we're going to be using for the covariates. And then he's looked at whether they have a pregnancy-related condition code, either all days prior and 90 days before. Basically not in the last, so they have to have had the first code in the last 90 days. So he's saying they have to have 0 of these, of this conditions anytime prior up to 90 days before. So he's looking for first-time pregnancy. And then he's looking to make sure they actually have one code 90 days before up to 90 days after. And it has to be a condition occurrence and observation. So if we look at the pregnancy concept set, it must have observations and conditions in the included. So if we look at the included, there must be observations here that he's, so the domain, he's got procedures and observations. So actually we should actually add in procedure of as well if we're being correct. So that's a little cheat that I do. If I look at the concepts, I look at the included and I see what domains they're in, and then I'd make sure they're all added. So really we should have a procedure occurrence. 90 days before up to 90 days after. And we want at least one of those. And we're going to make this the pregnancy-related finding. So this is basically finding someone who, for the first time, has a pregnancy, has an SSRI anytime. So it could be their fifth, their 100th time. It could be the first time. At least 365 days prior observation. And then in the 90 days before or after, they have a pregnancy code, and they don't have any pregnancy code before that 90 days in their record. And we're going to be looking at the first time that they satisfy this. So we're only going to have a person once in the cohort table. So,
so again, so there's a problem with the code set, and that's the code set. The code set includes deliveries as well as indications of pregnancy.
is it?
So it's a problem. It's a problem with the code set. If you use the hierarchical definitions of the diagnosis codes, you have both pregnancy initial and pregnancy terminal codes within that same hierarchy. So you actually have to be very careful around like which ones are pregnancy indicators versus pregnancy termination codes.
So this actually links them. So these are the cohorts that Patrick made quickly.
Okay.
But one of the things.
I'm just saying I've done a lot on this, and so just be careful.
So one of the things is, so this is something that, so in the data we have here, the simulated data, we don't have pregnancy episodes, but there is actually a paper that was written by Amy Macho, who has an algorithm that will actually predict the start and the end of a pregnancy episode. So you can add a pregnancy cohort. So if I was doing this internally at J&J, I would use that cohort. So there's a paper by Amy Macho on actually using the CDM database to impute pregnancy episodes. So she has instructions, and there should be code online. If people are interested, I'll have to find out the links and I can send them across. But yeah, it will tell you, so she looks at all the different pregnancy codes, and she actually tries to impute, based on the delivery day and based on this code, when did it start, when was conception, when did they deliver? And she actually has the episode, and it will say whether it was, they will say the outcome, whether it was a live birth, whether it was an abortion, all the different types. It has the length, so you can even say, I'm interested in pregnancies at least 20 weeks or so. So that's what we did when Patrick mentioned the Jill's algorithm. She actually used that algorithm to do the prediction. So that's actually quite a neat thing that you can do with the CDM.
Question. It says exactly 0 instances of pregnancy-related finding all days before and 90 days before. Does that mean this is considering the first pregnancy?
Yeah. So that's what so because we don't have the pregnancy algorithm, that's what the hack that Patrick did.
Okay.
But yeah, if you had the pregnancy algorithm, you could just say earliest pregnancy episode.
Sure. Okay. Thank you.
So this one, we're not actually going to run because we're not going to have any of the pregnancy results in the simulated data. But just to show you, and then if I exit this, I'm not going to save it, as I mentioned, even though you probably would have wanted to add the procedures. And then that was gestational diabetes. So the outcome would have been the gestational diabetes condition occurrence, and he's looking at the earliest event. And this is because we're looking at first-time pregnancy. They shouldn't really have gestational diabetes prior if it was a true first-time pregnancy. A lot of the times when you actually create outcome cohorts, I actually suggest putting all events so that you can do the filtering. You can say remove people who have it prior, and you can do lots of different filtering. If you do earliest event, then you're only looking at the first date in that table that I was showing you when you try and look for whether they have the outcome. So you might miss it if they have the outcome later on because they might have had it prior and you're using that first prior, you're using that date only. So it's a good thing to just use all events. Unless you know with your target population it's not going to be an issue. Okay, so that was the pregnancy one that we were thinking of doing, but at the moment we don't have the data to support that. So let's look at the cohort or the prediction we're going to focus on. So we were looking at first-time users of this drug with at least 6 months exposure, so cohort 25. So here we're going to have a drug era of that drug, and I would imagine if we look at concept set, it's just going to be the ingredient and descendants. So we've got this is an ingredient and all descendants, and he's added another drug that must have been missing. So Patrick must have had some insight about this drug, because generally we just use ingredients and descendants. So first time that they have that drug, we've put the first time in the patient's history. So if the patient's had multiple observation periods, this will actually say that they have to have this drug for the first time across all observations. If you don't have this, it will just be the first time per observation. So you could still get people in multiple times. It's not that common, but it can happen. And he said a drug era of at least 180 days. To get that, you have to be exposed for 6 months. So he used the error table that basically tells you your start and your end date of a drug, and has already done the collapsing for you. Again, he's linked to the earliest event that satisfies this, and he said that they must have they must have had an atrial fibrillation in the past. So he wants to make sure that they're having the drug for the AFib. So they have to have a condition occurrence of AFib any time prior. So that is the target cohort. But he actually found that when you ran that in the data, actually, let me go back to that one, 25. When he generated it in the simulated data, we had 0 people that satisfied that. So he did a little bit extra work, and he actually just expanded it to any anticoagulant. So we click on the cohort 26. Now we've got an anticoagulant for the first time in a person's history. But the problem he had here is that because you're looking at multiple drugs, you can't do the restriction of the era length of being 6 months. So he had to be a little bit sneaky, and he actually manually did it by saying they have to have another anticoagulant 60 days to 120 days after, and 121 to 180 days after. So this is just a sneaky way of effectively saying an era of at least 180 days. And then again, he has his AFib in the history, and he's limited to first time, and he's got a 1 year prior observation. So this is the T, and when he generated this, it gave us 1,618 people. So not the biggest because it's simulated data, but it's still enough for us potentially to develop a model. Let's look at the outcome. So the outcome for this one was bleeding. So if you look at bleeding, he's defined this as condition occurrence of a hemorrhage, gastrointestinal hemorrhage, and it must have been within an ER or inpatient visit. In this case, he's put the all events, like I suggest. It's always good to put all events, and you don't restrict on the prior observation because you're doing that in T. So if someone's had this outcome after their T, you know that they've had the prior observation because that's already fixed in the target population. So if we generated this, he got a lot of results. But how many do we get in our T population? If you go to the incident rate option, I actually already have it open because I looked at this earlier. So he has an incident rate analysis number 4, is risk of GI bleed in anticoagulants. He selected his target cohort, he selected his outcome cohort, and he selected the 6 months to 1 year, which is what we want to do the prediction for. It's because we said that they had to be on it for 6 months. So we want to start the prediction from the 180 days all the way to a year. And for this one, he actually showed that there were 70 cases, pretty much. The interesting thing was that the person count went down. So we just looked at the cohort generation. There was 1,600 people in the cohort of the anticoagulant new users who are on for at least 180 days. Now, the reason this goes down is because the incident rate removes anyone who's had the outcome prior. So that means 600 people out of that 1,600 population had already had an bleed. So they've already had the bleed, so they got removed. So that's actually something that's worth noting down, is that a lot of the people in RT have already had the outcome before they're actually eligible for the prediction. So that was stuff just recapping the cohorts that I think most of you would have worked on. Now it's going to be the fun part of how do you actually create a prediction from this. So feel free to follow along if you want to build the prediction with me. You can build your own prediction as well, just picking in the cohorts, and you don't have to listen to what I say or what we decide for the settings. You feel free to pick your own settings as well. So if you go to this prediction button here on the left-hand side, and you click on that, you're going to have the option of a new prediction, a patient-level prediction. You have a table here which tells you all the predictions that have already been done. So if someone clicks this new prediction, you'll see their prediction now as another row. So if I click here and enter the name, best prediction ever, that would come up now as a row that you could go into. But I'm going to start a new one. So if I say new prediction, the first thing you want to do is change the name. So by default, it says new patient level prediction. I'm going to call this best prediction ever, if I can spell correctly. 2019. So then the green button saves that for me. And then you have the specification. So the specification here, we're going to define everything that we basically for developing the model. So we're going to pick our target cohort, so who it is we want to do the prediction for. So if you go to this add target cohort button here, you get a drop down of all the cohorts that you've created in Atlas. So we wanted to pick the new users of anticoagulants for AFib. So we go down to the row that says 26 with our cohort. If we click on that, it will then take us back to the original prediction page with a row corresponding to that target cohort. If we wanted to add another target cohort, we could go and we could put in, maybe we wanted to add the people who have the specific drug. If you knew you're going to have that in some other data, you might want to add that still. And that will add that as well. So then this will mean that we're actually going to be doing two predictions, at least two predictions, one for each of these target cohorts. If you accidentally put a target cohort in that you don't want, just press this red button and it will remove it. So once you've picked all the target cohorts that you want to do the prediction for, you don't have to just limit to one. You can do as many predictions as you want. You put them all in there. The next thing is the outcome cohort. So based on our best prediction ever, we're going to pick the gastrointestinal bleed. So that would be cohort 24. So we click on the add outcome, we get this table come up, we scroll down to the outcome we want to add, and we click on it. But if we wanted to, we could add another outcome as well. I'm not going to, just for now, let's just focus on this. But you're going to have time later on to play around with this, so you put as many T's and O's as you want when you run it. The only thing is, the more prediction models you have, the longer you're going to have to sit and wait for them to run. So that's the key thing, your T and your O. The next part is the analysis setting. So the analysis setting has three sections. The model setting, so what classifiers do you want to actually try? The covariate setting, what covariates do you want to try? And the population setting. Now, you can put in multiple models, multiple covariates, multiple population settings, multiple T's, multiple O's. And what happens is it does the Cartesian project. So every combination of what you put, there'll be a model developed for. So you can see the impact of, if I just do covariates of drugs, how would that compare if I put in just covariates of conditions? So in a similar process to picking the T and the O, for the model setting, if you go to this add model setting here, it will give you the list of all the models we have in Atlas at the moment. So we have more in the PLP package outside of Atlas, but these are the ones we have currently in Atlas. So who wants... is anyone want a specific one of these? Does anyone lasso logistic regression? Anyone thought, yeah, lasso? Okay, let's add lasso. So we click lasso. It's now actually going to come up to a screen specific to lasso logistic regression that tells you the hyperparameters. The nice thing about lasso, the only hyperparameter is the initial regularization value, and generally the default is pretty good. So with the lasso, you don't really have to do much. You can just press this back button and you can say, I'm happy with the default setting. And it will now be added as a row that you've got lasso logistic regression. It does an automatic search for this one. So with the lasso logistic regression, it was developed by Mark Schuchard, and he actually had it where you put in the initial regularization value and it will search to basically pick the best value. So it's quite nice that it doesn't require a grid. It just searches. So this is actually a nice model. If you wanted to add another model, you just go to add model settings, and then does anyone else want any other model? How about gradient boosted machine? Hands up, anyone want gradient boosted machine? Random forest? Okay. I'll put gradient boosted first, and then I'll add the random forest. So the gradient boosted machine, this is my favorite, other than the lasso. So I was a bit biased, I jumped to that one. So in this one, it's got a lot more hyperparameters. So when you click on it, again, you get taken to this gradient boosted machine page, and it has a lot of hyperparameters now. So you've got the learning rate, You've got the maximum number of interactions. So this is the interactions were basically how complex you want the trees to be for each of the basic classifiers in the ensemble. And then you've got the maximum number of rows. So again, this is controlling how complex it can be. The lower the number of rows, or the minimum number of rows, the lower the value, the more complex it can be, more likely you are to overfit. The number of trees to build, so how many iterations do you want to do? So boosting, basically, you learn like where you're misclassifying in the earlier trees, and then you build a new tree that puts more weight on things that you've done incorrectly. So the more trees you build, it's basically gonna, there's a point basically where it stops really learning, and it will kind of actually overfit and stuff. So this is actually a really important number to pick. I actually have, by default, it should look at when you start to make the prediction worse and stop. You can turn that off in R, but actually with the Atlas version, it's automatically added. So actually, if you add 1,000 trees, it will automatically stop when you've not really adding any improvement. So when I actually run this now, I actually just make this a really big number. If you didn't have the auto cutoff though, if it didn't automatically see when it stops adding the performance, like when it stops improving things, then you would actually have to put lots of values in here. The number of threads is something that isn't a hyperparameter. This is just a setting. So maybe we should move this out of this. It's pretty something that I will change in the future. But generally, it's just how good is your computer. If your computer is very good and it's got lots of cores, then make this big. If it doesn't, then you probably just want to put a value of 1 or something here. So in terms of these, does anyone want to add any learning rates? Are you happy with the 0.01 and 0.1, or do you want to add a different number? We could add a bigger number like 0.9, see what that does. Might get us something better, might get us something worse. Number of interactions, I find that 4 is quite a simple model, 6 kind of in the middle, 17 very complex. So I kind of like these. We actually need some research to identify what are the best starting parameters for the grid search. These are the default ones. There's going to be research to figure this out, which are the better default ones. But at the moment, this is what we have. So if we're happy with the parameters that we've got, we then press this back arrow, and now we see gradient boosted machines added. And then we had a shout out for random forest. So I add random forest now as well. So clicking on random forest will then give us the random forest hyperparameter options. So everyone happy with a max depth of 4, 10, 17 for random forest? Anyone want any other values added? We could add 8 if people want 8, or we could add what 2? We could make it very simple and have 1. I'm not quite sure what that would really do. The number of tree features. So this is how many of the covariates are selected per tree. The value of -1 is the square root of the number of covariates. So that is just the default, like what people who do random forest generally say this is a good thing to start with. The reason I put -1 is because if I put any other number, people might have actually had fewer covariates. So -1 just makes it nice. It works for any number of covariates people have. But if you know how many covariates you're going to have, if you knew you're going to have more than 2,000, you could put 2,000 here. You could put 10 here. I'm pretty sure if I create a model that only has 10 features in each tree, it's pretty going to be terrible. But I can put that in here. And then the number of trees to build. The more you put here, the longer it's going to take, but the more stable it will be. So with random forest, 500 is probably going to be okay. I don't want it running forever. And then we actually have a variable selection prior to fitting the model. I found that if you select randomly 10 features, for example, out of the 20,000 that are generated with the standard covariate settings, if you're generating that many, the model's terrible because chances are it's picking 10 variables that just have nothing to do with the outcome. They're just awful. So I actually did put in that you can do an initial variable selection where it runs a random forest, a big random forest to start with. It ranks the variables on importance and it selects the top 500 or 1,000 to select from. So this was just something that I added in because random forest was just doing very poorly when I didn't have this. But you can add it, you can get rid of it if you want to see the impact.
So can we see how many covariates we could have? How many features could we possibly have?
So that's a good question. Yeah. So when you so I'm going to show you. Let me go back. So I've turned this off false. So just a warning. So the random forest is probably going to be terrible. Just to show you what it does. It might take a while as well, but I don't think we have too much data, so it shouldn't be too bad. So with the covariate setting, basically you have an interface here where you can pick your covariates. So you can have some control in how many covariate settings you're picking, which will control the size somewhat, but you don't know until you extract the data how many, because we automate it, so it's any condition that anyone in your target population has had will get a covariate made for it. So it depends really on your population when you're extracting it. You can,
They have a lot of measurements, for example, they'll all become the covariates.
yeah. So you can have some control in that. If you want to minimize your covariates, you could just set I want some demographics, and you can say, okay, I only want conditions all time prior, and make everything else unticked, which means that you know you're just getting conditions, which would limit it. And you also have a setting later on where you can say the minimum number of people you want to have a covariate for it to be included, which can limit it as again, but you won't know really until you extract the data. So in the Mac, you get nice blue boxes. If you don't have a Mac, it comes up, I think, as a black box. So if yours looks different to this, it's just because it's the Mac interface. So with the covariate settings, the same way I did the models, I had this add covariate setting, and then it creates a row. I rushed that, so I've gone back to show you this. If you go into this row now, you can go back to the covariate settings you had. And then gender, who wants gender as a covariate? Everyone happy with gender, or should I remove it? Yep, have that one. Everyone want age groups as a covariate? So this is age in 5-year buckets. So are you 0 to 4? Are you 5 to 10 to 9? Are you 10 to 14, and so on? I think all the way up to like 95 maybe, and then I think 90. I think it's like 95 plus or something. Race. Do you want age? People want a continuous age in? We can add age. Race. Do people want race in the model? I personally don't like putting this in because most of the data sets don't have it well recorded. So we have one data set that has it and the rest don't. So when I want to transport a model, it's not going to transport. And if you're applying models and transporting them, I think race and ethnicity is going to potentially be a limiting factor if that becomes up as predictive. But I don't want to bias you. So if anyone wants it still, just you can tell me. But for now then, if I've got a quiet room, I'll turn this off. Index year, I would never generally put in for a prognostic model. If you're doing a diagnostic model, or you're trying to do a phenotype model, maybe it'll make use. You can make use of it because you might find that if you're trying to phenotype some illness, there might be some temporal changes. So maybe the illness is more common in history or more common now. So index year could be useful. But for a prediction model, index year has actually got a lot of problems because if you include index year in your prediction, you're gonna be using people prior to say 2019. So you might find out 2017 was a real big predictor of having diabetes. But when you're applying it, no one's gonna have 2017 data. You're gonna be applying it to 2019 onwards. So index year, generally, I would say no. Don't include that into your prediction unless you're doing phenotyping. Index month, if you think your prediction is gonna have some seasonality effects, you could add this. Does anyone have any reason to think index month could be useful, or should we remove it? And then prior observation time, post-observation time, and these variables, these are more for propensity score modeling. So if you want to match on things like prior observation, it doesn't make sense for a prediction. If you went in to see your doctor and he had a model and he said, okay, how long have you been in the database? You're probably going to look very confused. So I would generally not have that as a variable. And post-observation, I mean, that's going to be impossible to know at the point you actually chat to your doctor. So then I mentioned earlier that we have 3 different time periods for the binary covariates, and then it's any time prior. So by default, we look at a year, 6 months, 1 month. If you wanted to look at 2 years, you could change this to -730. And this is then going to be looking, did you have this condition in the last 2 years? I'm going to move this back to 365 though. And then end days is, do you want index date included when you're constructing the covariate? So things that occur on the day that you're actually indexing, do you want that included as potential covariates? most of the time I include it because I'll start my prediction from day one. So I start my prediction one day after index onwards. If you're starting your prediction from day 0, then you need your day index data is -1, because otherwise your prediction is going to be pretty much perfect for anyone who has the outcome on day 0. Your prediction is going to be perfect for them, but it wasn't that you're predicting. You're using the outcome as a variable. So we're going to stick to 6 months. So I'm going to keep this. Actually, we're doing 6 months, so we need to make this 6 months. So we need this 179, which I've never tested before. So I'm hoping there isn't a restriction on this being 0 or less than 0. But I'll put this. So this means that we're going to actually be using all the covariates up to the 6 months, because we're doing the prediction from 6 months onwards. Which means actually we're looking, medium term now is going to be like a year's worth of data, and long term is going to be a 1.5 years worth of data. And then the time-bound error covariate. So these are constructing covariates based on whether someone has an entry in the error, so the condition error or the drug error. Do we want to use this? So do we want to construct covariates for people who have a condition error entry anytime prior? Or in the last 1 year? Like, anyone thinking anytime prior? Anyone thinking in the last 1 year? Okay, so we're gonna ignore the condition. What about condition? So condition group, this is when you use the hierarchy. So this is when you're saying someone has a diabetes code or any child of a diabetes code. Do we want to use the condition group, which is the hierarchy, anytime prior? Anyone want this? Okay, anyone want it in the last 1 year? So condition group in the last 1 year? Okay, perfect. And then what about medium term? Short term? So in the last, a month up to the 6 months following? Anyway. So it will be slightly different because, so if you have in the last year, you're including the ones that had it in the last 6 months. But the 6 month one could be different because it will tell you, did you have it pretty close or did you have it a little bit further back? So it kind of gives you a bit more information about the distribution of it. So sometimes you might want long term and short term, or long term and medium, just to, if they're a yes for long term and a no for, if they're a no for long term and a yes for long, yeah. So short term I think was no. So what about drug? Do we want drug anytime prior? Drug long term? You want drug long? I'm going to assume the medium and short term we're just going to ignore because we can stick to long term. What about drug group? Anytime prior drug group? Long term drug group? 1 year? Okay. And I'm going to move this. Overlapping, again, isn't something you really generally use for predictions, so I would just ignore that. I don't. This interface is the same as when you do the cohort stuff. So if you're doing causal inference, you have the same interface. So you're actually learning part of how to do the cohort method stuff as well. But some of these are specific to that more than ours. Okay, so I'm going to get rid of the short term here. I'm going to untick everything, and then we can pick what we want to tick. Okay, say conditions we've already done in the errors, drugs in the errors, procedure anytime prior, anyone want that? Procedure in the last year, anyone want that? Yeah. Measurement anytime prior, anyone want that? Measurement in the last year? So measurement, if you pick this, will actually put the last measurement value, but a lot of data sets won't have measurements. So our data sets in J&J, we don't have measurements for the majority of people. So that's when you might decide not to put it in if you know your measurement data is not the best. This one is binary. So this is did you have a measurement? The value is, what was the latest value? So repeating that, is everyone happy with having the measurement binary? Yeah, okay. Do you want measurement value in the last year? Yeah, this one will be continuous. This one will be continuous, but the range group will kind of be categorical of was it a below average? Was it average? Yeah. So do we want the categorical measurements? Okay. I've never actually used these ones, so it's going to be interesting if they come up. Observation. Do we want observations in the last year? Do we want devices in the last year? visit count. So this is like a proxy for the healthcare utility in the last year. Do we want that? So we can either have the visit count like inpatient, outpatient counts, or we can have visits of like how many visits for conditions, how many visits for drugs. Actually, that might be a different one. That might be these distinct counts, actually, sorry. So this is, I think, any visit, and then this is the inpatient and the ER. So this is specific visit, any visit. Do we want both or just, yep. Okay. And then we've got some existing risk models we can have as covariates as well. So do we want any of the existing ones like the CHADS2, which give us information about maybe their cardiovascular? Do we want that? Do we want the CHADS2 VASC, which is slightly updated CHADS? The DCSI, I believe, is like a diabetes one. Do we want a diabetes one? Yeah or no? Okay. Okay, so we got all these covariates, and once we're happy, we just review it, and then we go back on this arrow here, and now we've got a covariate setting. If you wanted to try a different covariate setting, you could just add covariate setting and add that in. And then the last one is the population setting, and this is how you're actually going to be defining your time at risk, and also any of the exclusions that we mentioned earlier. So if you go to population setting, add population setting, you get to the population setting page. And then the first thing is our time at risk. So we were saying that it was going to be 181 days from cohort start. So we're starting 6 months plus 1. And then we're going to finish it at 365 days. Or we could actually expand that to like 500-ish days if we wanted. Minimum look back period, Patrick already specified in the cohorts 1 year. Is everyone happy with 1 year, or do you want more than 1 year? Happy with 1 year? And then should subjects without time at risk be removed? Yes or no? So as I mentioned before, based on research, I've actually found that it's pretty best to put no here in general. And then should the first exposure per subject be included? So do we want people who have, actually we're only, so this one's redundant in this case because we've looked at first time occurrence for RT. So we could put whatever we want here. But generally, I'd put yes just to be double safe. And also when you're looking back at it, if you look at your settings, you're going to know that you've only got a unique people in there. And then remove people who've had the outcome prior to cohort entry. So this is the one where we saw with the incident rate calculation, a lot of people had had the bleed before they got given the drug. Do we want to include them or not? What do people think? Does it make sense to include people who've had the bleed prior? So I think in the pregnancy we excluded people, but I think for this one, did we in the cohort exclude? I'm not sure if we did exclude people with the prior bleed. No, in fact, in the incident rate we did. The incident rate it removed people, so we in RT we definitely have people who have it prior. So like basically now we have the option: do we want to exclude them if they had it prior, or do we want to include them? Is it that maybe we want to remove people if they had it in the last month, just to make sure it is a new bleed that we're predicting? Maybe we could do that. I must say, like, this is subjective. Sometimes you might know why you want to remove people. Sometimes people generally who have a GI bleed are probably going to be at high risk of having it again if they take the drug. So it might be worth keeping them still. So let's remove people if they had the GI bleed in the last month, just because we want to make sure we're getting an outcome that isn't occurring before the T index date. So once we're happy with that, we can press the back button, and we've got all our settings. The last thing is, do you want to sample? If you've got a lot of data, we're going to say no because we've only got 1,600 people. Minimum covariate occurrence. So this is saying that at least 1 in 1,000 people have to have a covariate for it to be included. We've only got 1,000 people, so this is just saying like if one person has it basically at the moment, or 2 people have it, they'll be included. So this is pretty reasonable. We've got smallish data. Normalized covariates, because we're doing a lasso logistic regression, we should normalize it. If you're just doing tree-based, you wouldn't have to worry about that. And then the training settings. So how do we want to do our test train split? So we have the time or the person option. So who wants to do person? Hands up. And who wants to do time? Okay, good. So person is 1. I'm glad because I was worried that it might be about 50-50 and I'd be hard to figure out which is which. But And then percentage. So we've got 25% in the test set, 75% in the train set. Is anyone unhappy with this? If you are, if you're unhappy, speak now. Otherwise, we're gonna continue. And then, sorry? We had 70 events when we excluded people who had it prior, but a lot of the people would have had it prior. So maybe quite a lot of events when we include in prior, potentially. And then the number of folds, we've got small data, so let's do 10 folds. Not 310, we might be here for a while. And then seeds. So if you want to put a seed so that you can repeat your settings and get the exactly same results, you can put a seed here. I normally put the time. So it's 255, I'm putting 255 here. And then once you're happy with everything, you press the green button to save. At this point, you could exit or copy. So if you were happy with this, but you wanted to make one slight change, maybe to your T, you could copy this and then change your T and save it. So if you wanted to start from some entry that someone's already done or you've done, copy is quite handy to just skip some bits. But I'm going to assume we're not going to copy. We're just going to go to actually implying it. So in the utility tab now, it will actually enable you to review what you've actually done. So you can see each row what you're going to be predicting. So we've got 3 models: the lasso, logistic regression, the gradient boosted machine, and the random forest. We've got our model settings. We've got our T and our O, which is the same because we've just got one T and O. And then we've got our time at risk. So if we're happy with this, we can then just put any value here. So this is basically all the work you need to do for the prediction. This is, if you enter in a value here, so I'm going to call this best prediction. If I spell correctly. Typos like that keep me entertained for hours in R code whenever I'm doing like programming. Where's the error? It's because I've got a random T in there or something. So once you've put the name in, you can then press this download button. And when you press this download button, Atlas now generates an R package that will contain all the functions that you've specified based on what you specified to develop the models you want. So it will extract the cohorts and the SQL to create the cohorts. It will extract, it will basically get all the settings for all these models and their hyperparameters. And then you can see, basically, I'm going to run it in the RStudio, and you can run it along with me to actually see what we get. So once you're happy with the name, you press this download, and it's now going to download the results into it goes into my download folder. So in my download folder now, I should have this zip, and this will be the prediction model. So if I go into here now, it has basically an R package. So this is the R package containing all the information I need to run the model. With the Mac, when you double click it, it automatically decompresses it, which is quite nice. With the Windows, you're going to have to unzip it. So if you download this in Windows, you can't just double click on it. If you have a Mac, you can skip the uncompressing it. So all you have to do now is go to your RStudio session. So let's go back to the link. So now we're going to switch over to this website. So now this is where you're going to need your username. And then the password is going to be password1. So if we go to this RStudio link here, so if we go to this link up here, am I just doing this wrong? So we go to this link here, so rstudio.plp, Odyssey tutorials.amazingawsdemos.com. You should then get an option where you have to put a username and password. So I'm going to give everyone a few minutes to get there. And even if you have no knowledge of RStudio or R, you should be able to still run this. So that's the good news. Atlas pretty much does everything for you. Okay, so I'm going to try and find that website myself now. So I actually already logged in earlier. So hopefully no one went to user 80 because it's the one I'm on. I think it would have kicked me off if they had. So now what you need to do is you need to actually upload the folder, which I think you might want to create a new folder first. So I'm just going to call this PL. Oh, actually, no. Sorry, you can upload your zipped folder, actually. So if you're building the package locally and not through the Amazon cloud, you want to unzip your folder. If you're uploading it to Amazon, you actually want to upload it as the compressed zip folder, and it will unzip it for you. So here we actually just want to choose the zip folder. So if I go to my downloads, so if you go to the upload here, so this upload here, you then have this choose file, and you can go to the location, and you want to get your zipped one. And if you press choose, if I've remembered correctly, it should now just create a folder. I don't want to upload. Maybe I'm going to do a new folder just in case. PLP package. Okay, so it probably is worth, actually, in hindsight, worth creating another folder to put it in. Otherwise, it wants to overwrite your ARF script, which you don't want to do. So in the PLP, I created this PLP package, went inside it, pressed upload, and then I selected the zipped folder that Atlas generated. Is everyone happy with following this? Is this? I tend to go fast, so if I'm going fast, just shout at me and I'll slow down. So once you've got this, the only part really you need to do is you need to build this. So there should be an option for building it. If you go and click on the R project, so you need to click on this R project. So this file here that I've ticked, but you don't want to tick. You want to click on this, and this is going to open the R project. So this will then enable you to build it locally. So if everyone's got inside of their Atlas generated folder in the RStudio, you click this and it says, do you want to open the project? You want to put yes. And then once you've clicked that, it will now enable you to have this build button. So if you're inside your project correctly, it should enable you to have this build. And what this is going to do is all of these files are basically instructions to create a library inside your R. So if you've used R before, when you use R, you generally install libraries. This is your library. Once you've pressed build, it's going to have created a library named best prediction in my case, or whatever name you put in Atlas. So if you go build now, and then you go to install and restart, you'll then see instructions. It will actually pop up here, and it will tell you whether you're successful or not. So if you type install and restart here, if all has gone well, you should get this information here that's told you that you've basically built your package, and now you have this library, in my case, best prediction, available. Is everyone following this, or any? Is this okay? Okay, perfect. Okay, so now we go back to the environment, and we go back to files, and then in the package that you uploaded, there should be an extra folder. So there should be extras. So if you click on extras and go inside there, you're going to have 3 different R scripts. The only one you really have to look at is this code to run.r. So if you go to this code to run.r, click that, it will now open up a script. And you see here the first line is going to basically loading what you just created. So you've created this library, best prediction, or whatever you've called it. And the first line here is going to be loading that. And once you've loaded that, that's basically got all the functions you need to create your model and evaluate it. All you have to do is specify where you want your results, where you want to save some temporary data. So this is, you're not really going to have to pay too much attention to this, but you need to make sure that you point it to a location that has enough space for big data. Then you need your connections to your database. And then some information about the database schemas and the cohort table. And then everything else, all you have to do is pick what you want to run. So right now, this is basically saying false. Everything's false. Right now, if you ran this, it wouldn't do anything. But if you wanted to create a protocol, you could put true here. If you wanted to create cohorts, you could put true here. So this is the only thing you have to do code-wise. It's just changing this F to a T if you want it run. So I'm just going to show you how you can put the settings in. So the first thing is the output folder. Where do you want your results saved? What I tend to do is I go to my home. So right now we're in the PLP package extra. If we press this home button, it will take us back to the home directory in our studio. So in this home directory, you should see the fftemp, the my results, the PLP package, and the R folder. So the PLP package, this is what I created. This is where my R package from Atlas was. Oh yeah, so did you, when you uploaded your Atlas, did you call it, where did that go? Yes, yeah. So I called it PLP package, but it would be what you called it. So my results is empty, so that's perfect. So that's been set up nicely now. So what I would put in is I put this location of my results into this output folder. So you can check. I'm just going to double check what directory I'm in. Session. Okay, so you want to make sure you're in home for the working directory. So I would choose that. So if you go to, let me just show you how to do it. If you go to session, set working directory. We're going to do it from home because it will be a bit easier. Then you want to go to choose directory. And then you can pick, right now we're in the PLP package, but we want to pick home. So if you pick home, you should get these 4 folders come. Well, you should get the 2 folders, fftemp, my results, whatever folder you named, and then the R folder. And if we say choose, it's basically just setting our set working directory to home. And then we can say our output folder, because we're relative to our home directory, we can put our output result as just my results. So /my results. So this means that any results that we generate is going to be put into here. And then the next step is putting in where we want our temporary data to be stored. And in this case, we want to do the fftemp. So we're going to do similar to what we did up here. We're going to want to put the /, because this just is basically saying in my home directory. And then we're going to put fftemp. And this means that the data that we extract is going to be put into this folder. So when we're extracting the data from Atlas, it's going to come into this folder. Then, and is this big enough? Can everyone see this okay, or is it better if I zoom in? See if I can zoom in. I'm just going to move this around so we can get a better view of this. Can everyone see this okay? Okay, so then the next thing is, in the RStudio session, there's actually been a folder called connection details that's .r, a script that basically has already been written. If you click on that, it will now open another tab next to your code to run. So you know I've got connection details open. If you want to go back to your code to run, you can just click on that tab. If you want to go to connection details, you click onto this. And this has the connection details for the database that you want to use. So we have a Redshift one, we have a Postgres one, and then we have, this is actually already set our fftemp, so we could have cheated and just used this script to set our fftemp. And then these are all the different databases. So this is when you're running this locally, you would need to speak to your data administrator to find out these settings and to find out the names of where the data are stored. But for now, this contains it all. So for us, this is what we need. So we're now going to actually copy these across into here. So we should have a DBMS, a username, a password, a server report here. So these are all the values that we need to extract from here. So I just need to figure out which connection we should be using. I'm going to say let's try this one first. I've tested this before and one of them works and one of them doesn't work, but I haven't tested on this environment to know whether they both work or that's the case. So if we use the first one, so if you just, let's try the Redshift. If this doesn't work, we might have to go to Postgres. So we go to copy here and then go back to your code to run. And then you want to paste this in over, and then you can delete this one. So you can delete anything that came between the FF temp all the way up to the CDM database schema. You can just delete that and replace that with this cohort this connection details. Is everyone following this okay? Or any questions? Okay. So once you've done that, the next part is going to be putting our database schema in. So I'm just going to check to see where we created our, so this is my Atlas prediction. So in here, there's a configuration that basically tells you the databases. And I believe we used the SimPuff 23 million. So this is so Redshift is the correct server, which should be, hopefully. And then we want the CDMS SimPuff, okay. So now, in the connection details, at the bottom, there should be one that says the 23 million for the SimPuff. So I believe it'll be this one. So the CMSDES SimPuff 24 million. This is the CDM and the cohort database schema that we want to copy across. And we want to put this into our code to run. So we want to put this into this area. So I'm going to put this below for now because we actually want to change our database name to something. So I'm going to call this, this is basically, you can call this anything you want. There's no right or wrong to this. This is just the name that you're going to be calling your data so that when you're looking at your results, you know what the database was rather than these hideous strings that you often get in the schemas. So I'm just going to call this the 23 million. We don't have to do anything about 19 or 23. They'll be replaced when this gets run here. So I'm just going to leave them for now. We don't have Oracle, so the Oracle temp schema stays null. And then the cohort table, if we have, hopefully we all have permission, so we can just keep that the way it is. If you're using Atlas generated cohorts rather than generating your own, you just make this go to cohort, all lowercase. So now we've actually got all the settings. So if you've got the SimPuff settings across and you've got the connection settings across here, this is all the edits you needed to make. So now we have the option of picking basically what we want to run for the analysis. So in this execute function, the main ones are the bits that say this false settings here. So create protocol. Do we want to create a study protocol automatically with all the settings that we've defined in Atlas that we can share with people? Do we want a Word document? Yeah. Okay, so we put this to true. Create cohorts. Do we want to create a cohort? So this generally is best practice to put true here. So if you put true here, it's going to, when we actually extracted the Atlas cohorts or the Atlas package, it extracts the SQL code needed to create the target and outcome cohorts. So this will just run that SQL based on your settings. So this is just good practice to put true here. Run analysis. If you put true here, it's going to develop and evaluate your model. So this is actually the run analysis that's saying, I want a prediction model. And it's going to do 3 prediction models. It's going to do the lasso, it's going to do the random forest, and it's going to do the gradient boosting machine. Create result doc. The result doc isn't the prettiest document. It's a Word document that just has a summary of what your models were and what your models, how your models performed. So I'm going to put false here just because it's not as fun. Package results. would be if you wanted to share your models with someone, it will actually remove any sensitive details. So if you've got settings, like we've got the connection details to the database, generally that's stored when you save your results. Because if I'm accessing my results, I already know my settings. But if you want to share your results and you don't want to give them your access to your database, then you can say package results true. That will remove any sensitive data. It will remove any results that are sensitive. So if there's like low counts, and it will then enable you to have a zipped folder of your results that you can share with someone. So you'll have a compressed results that you can just email to someone, or you can put onto some cloud somewhere. Create validation package. This is used if you have a good model. So if you have a good model and you want it to be validated by people, you can create another R package containing your model that you can then share with other people. You can put it onto GitHub. And like, if we should have enough time, I can actually show how to do that process. And then if you want to view your results, it's the create shiny. So we're going to say true here. I'm assuming that the code will run. It's untested that with the settings we had, but I'm assuming it's run. So I'm going to put true here. And then create journal document, we'll leave to the end. So you can change this. So I can change these settings and rerun to pick things. So these are the settings I'm going to pick: create protocol true, create cohorts true, run analysis true, create shiny true. And I'm happy with all my settings, so I'm going to press source. And if all goes good, we should start to see the progress of it creating the cohorts. So it's this source button basically is going to run this whole script for you that you've entered. So it's run, which is good. So it's always nice when things work. So right now it's creating this gastrointestinal bleed events cohort. So it's going to create this is our outcome, which is the biggest cohort. And it's going to create our target cohort. And then once those are created, it's going to extract the data. So it's going to create the features. So we're going to see that would be the next step after we've created the cohorts. And then it will start developing the free models. And you'll have an output of the progress report for those free models being run here. So while this is going, actually, in this one, I can't do another session. So we're kind of stuck here. But I could show results or log in. Potentially. Actually, this should be pretty quick because it's actually quite small cohorts. So this next one should be much quicker. And then the extraction should be pretty quick. So generally, if you have 1,000 people in your target cohort, everything should be super, super quick. Even if you have, I would say, 200,000 people in your target cohort, it takes maybe, for the computer I have, an hour, 2 hours to do everything. The more models you select, the more hyperparameters, grid search you do is a bit slower. But I'm not often waiting that long for results. If you were to do something like deep learning outside of the Atlas package and in the R, it could take a lot longer, if you, especially if you weren't using a GPU. Does anyone have any questions while this is running?
So there's all these like standardized features that you guys have. I know earlier you mentioned that you can check in other features with develop SQL to create new features for predictive models.
Yeah, so the standard features are in Atlas only at the moment. So the custom covariates you can, or the custom features, you can do it outside of Atlas. But within Atlas, we don't have the setting to enable that yet. But I was speaking to Patrick earlier, and that's something that we do want to add in, because the code's there in the R code's there. It's just the Atlas interface to that isn't in there at the moment.
So how do we break this thing apart to like sort of get to like various steps in terms of like, say I only wanted the code that generates just the cohorts and the feature sets, and then I wanted to run my own, homegrown predictive model that I have. How would I go about doing that?
So you could either plug in your prediction model into the into our package. So each classifier we have, basically it has a set thing. So you have a set function. So it's like set gradient boosted machines, set lasso logistic regression, and that's like where you basically define the hyperparameters and the grid search or whatever search you want to do. And then we have a fit function that basically takes set inputs and outputs like set things like the results, that like it will be like the model, the prediction, all these different values. So you could either plug your own algorithm into that, Or you could just use the standard features, where you could use feature extraction to extract standard features and then write whatever R code or Python code you wanted with that data. So that will just, you'll see when this gets extracted in the My Results folder, there will be like lots of PLP data objects. And that's just the way we have our data, extracted data stored. So you could read that and then play around with that and use that for your custom. But I would recommend the best thing would be to plug it into the package, because it's just a lot more simple, and then you don't have to play around with things. If the package changes, you should be able to like go with the changes.
Just research that you guys have enabled, because we've been testing randomized hyperparameter search with like a Bayesian update model. So that's why I'm asking.
So Lasso has the automated search, but for the other algorithms, at the moment, it's just a grid search. So I want to add more flexibility. I also want to have it where we could at the moment, we optimize the area under the curve. So when we do the cross-validation and we find the settings that optimize the area under the curve, I want to have it so you can pick whatever value you want to, yeah. So I think that's something that we could get a lot of value from actually modifying that. But the moment for the grid search, it is just a grid. It's just a grid. Yeah, we just have a grid search. There's no intelligence to it. So.
But it's also something that you could actually add to the package. Not that we only have to develop the package. So if there's something you would like to add to functionality, we can do it and do a pull request to our package, and we can consider that.
Yeah, and at the moment, it's the search is specific to the algorithm. So if you added your custom algorithm, you could add whatever search strategy you wanted in there. That basically gets defined in the set function or in your fit function. Okay, so it's all working so far, so that's always good. So it was normally I test it myself, but it was tested by a colleague. So I'm just like, I'm hoping that I'm running it to the correct way. So we've got our 2 cohorts created right now, and right now it's at the point where it's constructing the features. So it's looking through all the conditions, all the drugs, all the procedures, all the measurements that we specified that we wanted in the last year, and it's creating those covariates. So it's going to create it for any condition, any drug, any measurement that anyone had recorded is going to have a covariate created for it. So there's going to be a lot of covariates, but then it's going to say they have to have at least, actually in this case, it's going to, the way we said it, at least 1 in 1,000 people have to have it, and we've only got 1,000 people in our T approximately, so actually it's not going to filter anything. So we're pretty much going to have everything that we specified. So the only thing is that I've never tried the measurement values, so I'm hoping that the measurement values don't have a bug in the feature extraction. Once the data is extracted, it should actually be a very quick process to actually train it. So the lasso, I should imagine, will take a couple of seconds. Sometimes we do find that if there's small data, the lasso won't fit. It won't be able to converge, and then you actually won't have a model. But that generally means that you can't do better than an area of 0.5 anyway, or around that. So. Is anyone else running? Some stuff? Oh, okay. Is it progressing similarly? Did you make any modifications, or did you keep? Oh, okay. We'll see how consistent the models are. Who managed to actually follow along with the creating the package and everything? Okay, perfect. So normally what I would do if I wasn't in this, I would create another session, I'd go through the results. But the problem is I tried doing that once and it crashed everything because you can only have one session open on this Amazon at the moment. True. So what we'll have is after we've run this demo, everyone will have the opportunity to basically play around and do whatever prediction they wanted. So I know we only selected one prediction within each group, and then we selected one overall. But if you had a prediction you really wanted to work on, feel free to start creating the Atlas cohorts and designing that. Yeah, so once this is finished, it should then, as long as everything runs fine, that I can view the Shiny interactive. So this automatically creates a Shiny app. Once this is all finished, if it runs successfully, you'll have a Shiny app that you can then explore. So I can see. This is simulated data though, so it's not going to potentially be the most exciting. But I can actually let me show you how to put it on GitHub. So if you wanted to put your package onto GitHub, so if you go to study protocol sandbox, this is where we put our packages network studies. So in the OHDSI study protocol sandbox, you'll see all of these folders, which is effectively the same folder that you created from the from Atlas. So if you look at some of the predictions, it will look exactly the same pretty much as the package you extracted from Atlas. So once you've extracted your package from Atlas, you can just upload, basically you can go to GitHub, log in, and put your package here, and then other people can run and do the same process as you're doing. So you could quite easily just share it. And we did this last year. We ran a study that we got lots of people to run in one day. We put it onto GitHub, we emailed people and just said run it. And then they should have instructions. So once you've put your package online, you have to modify the README a little bit. We haven't automated that, unfortunately. But it does have the standard getting started. So it will tell people like how to actually install. So this is the instructions for installing from GitHub. So we built it. When we uploaded the folder and we built it locally. If you do this install.packages, DevTools, and then use DevTools install GitHub, this will build the library from a GitHub folder. So this is pretty much the same process we did when we created our library, but it's from GitHub. So other people can build the library you had just from writing these code. And then they can do the same process pretty much that we ran, where you do this execute, and they could basically develop the same models you developed, but on their data. So this is how you can actually share the model development code and get it replicated. Just put it onto GitHub. I believe that you should be able to have access. Everyone should have access to this. If you don't have access to the GitHub to make a push to GitHub, you just email one of the people like either Patrick or Lee, I guess, and they'll give you permission to do that. Then once I've actually got the results, I can show you how to put the validation package up as well. So we're 37% now on the features. There's a CHADS2 tutorial as well here where we have different CHADS2 models. So you can basically redo the CHADS2 model on your data, but it'll be slightly calibrated. You can do it where you basically just replicate the CHADS2, and then you can also do it where you do the same prediction problem, but with all the variables to see like how much improvement you can do just doing automatic data-driven models. So this is like a really cool study to actually copy, and there's instructions of actually how to run the study here. Yeah, so the process will be exactly the same. If you have RStudio, the process is exactly the same. It's just the database connections. You just need to get those set up. So I think it's the hardest part, I think, of running a study is just knowing what the database settings are. Once you know your database settings, you can just run so many studies. So I actually have the Windows user authentication, like what I use. So I don't actually have to put any think. It pretty much just connects for me. And I have some settings just set as an R file that I just source. So when I run it now, it's just copy this and I say, okay, run this script, and then just I pick whatever I want to run on the execute. Okay, so we may have picked some features that are a bit slower to create, so it's not running as fast as it sometimes can. Okay, so we were having some issues with the results, and we found out that the issue was that the data, when it was actually extracting and being saved, there was like some sort of issue with if you hadn't actually put a specific directory in the output or the options. If you had done the .dash to say within this directory, save to this subfolder, for some reason there was some issue in this in the environment that it wasn't letting it save. So if you want to rerun it and get it to work, you just need to make sure your output folder and your options specify /home/user your number / my results and /temp. So you just need to make sure rather than there being a ./, just change /home /user and your number. And then we can actually look at the results, which seeing what the random forest appears to have done, it's done very poorly. But that was expected because I didn't do the feature importance first. So mine's actually now run. So if you change the settings of the output folder and the options, it will now save and run. And it runs very quickly once you've done that. So if I actually now, I can modify this to look at the shiny output. So I'm going to copy this execute across, and we can actually look at how our results did. Oh, actually, I already created the shiny, so I'm just going to view the shiny. So I uncomment this and say view shiny. It will now pop up. So this is the results. So once you've run the study successfully, you actually have you can go to, so basically all I did is I just selected this view shiny, uncommented this view shiny, ran it, and then it will pop up with the shiny result. But I'm not quite sure how to get there now, so I'm going to stop it and redo it. So you have the shiny result here. And this will tell you we had 3 different models. We had the lasso logistic regression, the gradient boosted machine, and the random forest. So interestingly, the lasso logistic regression didn't actually converge. So basically this is saying that there's too many variables and it wasn't able to actually find anything associated enough to the outcome for actually to run the model. So in this case, our lasso logistic regression failed, probably because we're using simulated data. Our gradient boosted machine actually had a model that on the test set did better than random. So our gradient boosted machine actually did pretty well, which is why it's my favorite. And then the random forest appears to have basically failed again as well. So the only one that really actually ran and worked seemed to be the gradient boosted machine. So you can actually explore this model by selecting it. And then you can look at what the settings were. So you can see the model, you can see the number of trees. This is the hyperparameters basically that worked. Population settings, we can see what our settings were. Covariate settings, we can see what covariates we selected in here. And then the more important part is actually in the performance. So we have this dashboard, so I'm just going to get rid of this just to make this a bit longer. So we have this dashboard that says what was our prediction question. So within new users of anticoagulants who have atrial fibrillation, who gets the gastrointestinal hemorrhage within 6 months following 6 months of continuous using of it. And then we have this dashboard that tells you at a given threshold, what was my positive predictive value, my negative predictive value, my sensitivity and specificity. So sensitivity, if I have the illness, what's my probability of my model actually predicting that I'm going to have it or get it. Specificity is just how specific my model is. So in this case, if we've got we've got a pretty low specificity, we're going to be getting a lot of false positives and such. The positive predictive value, actually false negatives. Positive predictive value 8.8 could be reasonable, but we actually know the incidence is 7%, so it's not actually doing much better than just saying everyone has it. And the negative predictive value is put here, which sometimes you might want to actually identify a group of people that have very low risk, and which in case you might want to look at the negative predictive value. If we increase our threshold to say, okay, people who have a risk greater than 0.1%, our positive predictive value actually went down and our sensitivity went down. So this is actually not very good. If we went a little bit further, hopefully our positive predictive value will go up. So we could say, okay, if we were to predict people who had were assigned a risk greater than 17% by the model, we'd identify a group of people that had a 10% risk, which was 3% higher than the actual incidence. We'd only get 12% of people who had the outcome being identified, but we've got our specificity up quite a lot now, so that's nice. So this is if you want to like play around to pick a point, a threshold for where you'd actually apply this model. And you have the cutoff performance here, just to kind of, you can see the true positive, true negative, false positive, false negative here. And then we go to the discrimination button, and this will then plot our ROC plots in interactively and our precision recall plots. So we can click on here. It will tell you at this risk threshold, the value was 0.06. We have a specificity of 55% and a sensitivity of 64%. And you can play around and toggle with all the different values here to see how it did. This is pretty poor performance in general. This is quite a bad ROC plot. But it was simulated data, so this is what we expect. And then we have the precision recall plot. So you can kind of, again, look at a given risk threshold, what was my recall and what was my precision. So recall, I believe, is the same as sensitivity, and precision is positive predictive value. So here we could identify 4% of people who are going to have the outcome, and they have basically 11% of them would have the outcome. And then we have a few other metrics for discrimination, which you can kind of look at, or plots for discrimination you can look at. And then the distributions, like Peter showed earlier, these distributions are used to show how you're actually able to separate the classes with the model. We didn't do too well, which is why they're overlaying. And then we got the calibration. So this model is not well calibrated. It's really because there's not many outcomes, and also the model didn't do very well, and it simulated data. In this case, we don't actually seem to have the demographic plot. It seems that there were not enough males who had in the data, so the male part actually has been excluded. And then I'm not quite sure what's going on. I'm not quite sure why this is so poor here. Simulated data is never fun. And then, so that's the Shiny app, if you want to explore it. And then if you actually get the menu back, you can go to the model. If you click on the model, it will actually tell you what predictors were put into the model. So you can see here, we got abdominal pain, seemed to be more common in people who had the bleed than the people who didn't. And we can look at, and we've got some digestive structure mass, some vomiting. So these are all things that seem to be associated to having a risk of the GI bleed. Things that seem to be less common were having some drugs, by the looks of it, some antibiotics, and some other drugs. And then sometimes this isn't the nicest to actually explore things because the covariate names are so long, so it's actually, you can look at the table instead. So if you want to look at things that had a positive coefficient, even though we shouldn't expect it too much, as we always stress, if you value by this, you can see the things that seem to appear to be associated to having the GI bleed, and you can see things that are negatively associated. Oh, so this is actually already, this is why the demographic plot didn't work. So this has actually got the sensitive information removed. So this is ready for you to share with people. If you actually wanted to have all the results, I need to change the settings so that it doesn't actually remove the sensitive data. So basically, when you say you want to remove sensitive data, anything with a cell count less than 5 is what I put. We'll get a -1 here. So people can't see that there's basically who has rare outcomes. So this is actually shareable. So you could put this Shiny app online, and you don't have to worry about people getting the data for like personal data. And that's why the demographic plot wasn't working, because the outcome rate was so rare. There probably wasn't enough people for each age and gender group for it to actually be plotted. And then you've also got the log. So in this case, it hasn't actually gone across, but sometimes in this area, you can actually see the log. And then you have information about how to use this Shiny app here. So there's a demo video. So let me run this without it removing. So I'm going to say min cell count equals 0. And should regenerate it. Hopefully, without the minus ones. There we go. Oh, so we actually had nothing that was had a negative coefficient. And then here's actually the variable. So this is the ones now I've actually made it so that we're not removing anything count-wise. So this is what you'd get if you want to look at it yourself. The other one would be if you want to share it with people. It's pretty much the same thing. And then we can actually look at the performance. And the calibration now should have the plot. So here we can see how well it was calibrated for the age and gender groups, which again, the calibration was quite off. But it was because we didn't have that many people who had the outcomes, so you'd expect quite a lot of variability. But this is a nice little app for exploring your results. So for every single model that you specified in your atlas, you'll have a row that you can explore. If you had real data and you had enough outcomes, they should all have performances and they should all have a model. This one, I'm not sure if the model would work. Yeah, this one basically it didn't converge because the data, it wasn't predictive enough that you couldn't even fit a model. And this one seems to be the same. The nice thing is about this as well, if you click on the model that actually ran, if you go to the model, you can actually click this download model that will give you a CSV of the variable, so the variable name, the variable importance, and how often it occurred in people with the outcome versus people who didn't have the outcome, or the mean value. So here you can see the mean age of people who had the bleed was 74.8 or 74.9. And then the mean age of people who didn't have the bleed was 74.2. So they were slightly older, although not that much difference. But you can see how they differ across all the different variables. Then the nice part about this is if we liked the model 2 and we wanted to create a validation package, so if our model 2 had been amazing rather than just running, we could have actually create a validation package. So I'm setting everything here to false. So everything here is false except for this create validation package. And then there's this analyses to validate. All I need to put here is 2 to say that I want to basically validate the second model, because it's the second model that seemed to do well, the gradient boosting. And if I write this now, inside my results folder, I should now get a validation package. So if I click here now, this is another R package that I can now put onto GitHub for other people to basically run to validate my model. Or I can use this, I can build this and validate the model on my own data. So if I went into this project now, built it, and then went to the extras, actually it should just be in the README. In the README, there's instructions for actually the code you need to run this. So I can actually now use this package to validate my own model on different data or to share with people. So you've automatically got a way of sharing your model. And as a best practice, we'd recommend to put this on GitHub if you're doing a publication so that other people can easily apply your model and also validate it. Or if you're doing a network study, this is quite handy as well. And then the last cool thing, once you've got your results, which is all in the execute function. So I'm going to remove this. I'm going to say false. I don't want to create the validation package again. But I do want to create the journal document, which I have to put an analysis ID for my journal document, which again, I'm going to put the second ID because that's the model actually did well. So for the validation package, you need to remember to put the analyses to validate. And you could put more than one model across. So if you put a vector 1, 3, 10, it would actually take the first, the third, and the 10th model and put it into the package. So you can actually transfer multiple models across. And then this create journal document, you need this analysis ID, which will tell you which model you want to create a journal document for. So we type execute here. Oh, apparently I've already got analysis ID here. So let's get rid of that one. Execute here. And now, inside my results, I should have a PLP document. So I'm going to go through. So when I ran this, I created the protocol document. So the protocol document looks like this. It's a Word document that basically contains all the settings that you specified in Atlas. So this is automatically generated when you actually press execute and you say create protocol. You get information about all the settings that you've done. So you unfortunately, we can't do the literature review for you, but everything else should be in there. So you've got your objective is to predict who's going to have bleed, new uses of anticoagulants, and you've got your time at risk settings. You have the study design. So we've got the nice picture that we showed about how you have the index, you use the stuff prior for covariates, and then you look after for the outcome. We have information about the links to some important papers like Progress and Tripod. So these are important review papers for prediction or guidance papers. You need to put in information about your database. We have information about our T and our O, so what they are. What I tend to do, I replace this with, if you go into Atlas, inside Atlas, if you go to your cohort, which would be here, and I go to my new uses of an anticoagulant, if I go to export, you have this user-friendly text view of what you've actually set for your logic. So I just normally copy this across. And maybe I go all the way up to here. And I put this into the protocol. So I just replace that with this. So I don't even have to write anything for this part. And I do the same for the outcome. Then you have information about your time at risk. You'd have more rows if you picked more time at risks. You have information about your population settings. You'd have more tables for each population setting if you had picked it. And then you have information about the algorithms you selected. So whichever algorithm you select, you'll get a row for. Then you have information about how we're actually going to evaluate the model, so all the different plots or metrics, and how to actually interpret those plots. And then you have information about quality control tools, diagnostics, and data analysis. So this has got all the settings that you picked in Atlas is now in this document. And all you have to do is copy across the Atlas cohorts as the text-friendly version, and then into information about the data sources, put it in the background, and you can use this as a protocol for network studies. So you can then put up your package that was generated by Atlas, add this protocol that's pretty much pre-generated for you, and ask people to run your study for you. So that's the first document that it creates. The second document is if you've picked a model that you like, and you've, so in this case, I picked the second model, it will create this PLP document.docx. If I click on that, it's going to download it for me. And this has a document that is pretty much ready for publication once you've added a few little bits about your development data set and such. So here you've got the title, which follows the tripod guidance, development and validation. Obviously, if you didn't validate, you'd have to get rid of this validation part. But we recommend it's pretty easy to do validation with the validation package that gets generated. Then you have the abstract that tells you the objective, your study design, settings, participants, outcome, predictors, and so on. Then you have to put in your literature review again. But if you've done the protocol, you can copy and paste what you did for the protocol into this. Then you have information about what you're actually predicting, that you follow the progress in a tripod. You need to put in information about your data sources. If you did a protocol, again, you can copy and paste that in. Target population, outcome. You probably need to make it a little bit more user-friendly than the Atlas version, but it's pretty much just revising that. Then you have information about your predictors. We recommend you just clarify about missing data. Most people ask how you handle missing data. So what we do in PLP is effectively, if you don't have a record, you're considered as not having the condition or the drug. So we effectively impute 0 for people. Then you've got the statistical analysis. So it would say about the one that I picked was a gradient boosting machine. So it says what was picked. It says you did tenfold cross-validation. It tells the person that used patient prediction and that the time to train and validate was 1 minute. So you have all that in there. You have information to say that you're going to evaluate it using the AUC and the calibration plot. You have your attrition table. You have a covariate plot. So this is just telling you for every covariate you had how often it occurred in people with the outcome and how often it occurred in people without the outcome. So anything above the line was more common in people who had the bleed. Anything below the line was less common in people who had the bleed. Then you have your model specification. So it tells you that you had a potential 12,251 predictors, but you only selected 35 into the final model. And then we've got a recommendation of actually putting in how you can actually use your prediction model as tripod recommended. Then you have your rock plot here for your, I guess this is the test and this is the train. So we definitely overfit there. Then you have your calibration plot for your test and your train. Then you have the discussion. So you need to discuss how you'd use the model, implication, limitations that are pre-done. You might want to add in your own limitation, maybe have some limitation on the cohort design. Conclusion, which you might need to revise a little bit. So, for example, adding in why it's useful. But all the details are already in there. The error in the curve is already, the AUC is already there, and the 95% confidence interval. And then we have some pre-done references. We have information. This is the actual model itself. So these are the 35 variables and their coefficients. So hopefully this follows the tripod statement pretty well, but you will have to add in some information. But if you had, it's less impressive this time because our model didn't do very well, but if you had a nice model, you're pretty much halfway there to getting a publication somewhere. So this all gets auto-generated by Atlas once you've picked the model you like. That's pretty much it for all the protocols. If you have done the validation, it will also enable you to, if you've done a validation and put in results, so what I tend to do is I will get people to validate our model, and then I'll put the results into this validation folder. If you had results in here for the validation, the journal document would automatically also add in the external validation results. So not only would it have the document for the actual development, it would automatically say, okay, it got external validated on these database names, and here's the performance. So it also does that for you as well. And we recommend as best practice to validate externally. So any questions on the execute? If not, I'll hand back to Peter to summarize the rest.
Thanks. Right. So just to wake you up a little bit, I think it's very important to realize what we actually did today. So we specified a prediction problem in Atlas. It's just something we decided today. And then we were able to download an R package after specification of all the settings that we can run against our common data model. So without doing any programming, the only thing you had to do is the specification, so the connection details of to your common data model. We were able to execute that R package, run it on data, but also created an external validation package that we could actually now distribute to other people who also have a common data model to test the model that we fitted on our data. But we took it even a little step further, that we also generated some documents that you normally had to write from scratch, like a protocol and the results document. I think that's very, very nice. And it allows us to do all kinds of different sensitivity analysis as well in a very easy and very straightforward way. Normally, it would take a lot of time to do what we have done now in the morning or in this day. We are all almost getting used to that because we are giving these presentations a lot. But I think it's very important to realize that this is actually very, very nice, I would say, to get from an idea to executing a study, to looking at the results, to generating a Word document that has all the results in there, following the tripod statement. So I think today you just make the first steps in learning the whole platform, and we realize it still will take some time for you to be able to do everything by yourself. But we really hope that you get a kind of insight in what we've been working on in the last couple of years by now. And there is a paper that describes the framework. It's in JAMIA. So I invite you to have a look at that. And also, of course, we now have the Book of OHDSI, which has a chapter on prediction that you can look into and learn all the individual steps that we've done today. Jenna already mentioned that there's also there's a result environment called data.odyssey.org, where we can store the results of studies. So have a look at that. There's the Shiny applications are there as well from previous studies that we've run. And I just want to mention that last year we had a nice experiment because we asked at the start of the symposium what people's favorite prediction problem was, just like we did today, and we did voting as well at the start of the symposium. What people didn't know was that backstage we had a whole team waiting to take on that question with clinical experts, with the data scientists and other people. We worked on implementing that whole study like we did today with you, but got a little bit further by also externally validating that model during the symposium day. So I think that was really an achievement. We were able to run that package against data sources in Stanford, Colombia, and South Korea, and other data sources, and showed at the end of the day a Shiny application with all the results. And it demonstrated how quickly we can go from a question to results. So if you are interested in joining the community, we do have monthly TCs, and you're all welcome to join that. Also present your own IDs, and there were some people in the audience today that had IDs maybe to extend the package, and please just participate in this journey. It's not something that only Jen has to program or a small team. I think we can all together add new algorithms as well in the package that could be very useful for the whole community. So we are still on a journey, and we are still adding functionality in the package, but also want to do many more studies with the package. So on more databases, on more target cohorts, more outcomes. And we do a lot of methods research, because you need to be aware that the framework that we build now opens up all kind of possibilities for us to do research at a very large scale. Of course, looking at performance, but the transportability question is a very important one. How well can we transport models in general by doing many studies and pushing that to multiple databases. There's a lot to be done in feature engineering, like temporal relationships between features, looking at the deep learning models. And ensemble training is something that we're looking in, and learning curves. There's a lot of possibilities to expand the package, but also our research focus. So tool development is ongoing, adding a model library where we can store all the models that have been developed, and maybe also update some of the viewers in the future. I want to end there. I want to thank everybody in the OHDSI community that has participated in this work. It's not only me and Jenna. There are many people out there that helped. Also like to thank AWS for providing this environment, and our faculty. Of course, thank you as well. Thanks. The last slide is if you have feedback, and I know some of you had already talked to me, just go to this link and there's a feedback form. I mean, we really like to learn more from you and give some feedback to improve the course later. So thank you very much, and hope to see you soon. Thank you.